Right, this would have been the short session. So it's the 1 hour session in week 8. Okay, because we was doing revision then, exam paper revision, and this is May 2016, and I'm going to do questions 2 and question 3, which may take more than an hour, but we'll see. I'll just put it into the slot anyway, so at least then it's done. So this is week 8, it's the 1 hour, the short session, and this is the paper we're working on. Okay, so these are the questions. I'll upload all this into the, there's 2 questions, question 2, and I've set up some blanks there, and question 3, I've set up some blanks there. So that's what we're going to do. I'm going to work through these 2 questions, question 2 and 3, and then upload it into Panopto in the short session in week 8. Right, so it's May 2016. Right, this question 2 has got parts A and B still to do, and a C and a D. That's right. And then 3, there's A and B. Yeah. Question 2, A, B, C, D. Question 3, A and B. Right, so 2A part 1. Integral of between 0 and 3 of 1 over x plus 2. So you may know that if it's 1 over x, it's log x is the integral. If it's log of 1 over x plus a constant, it's log of x plus that constant, and in this case our constant is 2. Between 3 and 0, so this is log 5 minus log 2, which is going to be log 5 over 2 is the answer. We don't need a plus c. Okay, when we've got limits, we don't need to put a plus c. Right, this integral here, if we've got the integral of a derivative on the top and the function and its function on the bottom, so function on the bottom, derivative on the top, that's going to be log of the function plus c. But we don't need the plus c because we've got limits. So we see here, this is 2x and this is x squared. So this 2x is the derivative of 1 plus x squared. So this is ln 1 plus x squared. Because if we differentiate this, we'll get 1 over 1 plus x squared, because ln is 1 over 1 plus x squared. But then we've got to multiply by the derivative of the bracket, which is 2x. That goes in there. So this is going to be ln 1 plus 9 minus ln 1 plus nothing. Ln of 1 is nothing. Okay, so this is the answer to this one is just ln 10. Okay, so next one, use partial fractions to evaluate the integral 2 over 1 minus x squared. So it's the integral of 2 over, first thing to know is it's 1 plus x times 1 minus x dx. Okay, so our partial fractions, we're going to find the partial fractions for 2 over 1 plus x, 1 minus x. So this is a over 1 plus x, and then plus b over 1 minus x. Multiply both sides by 1 plus x, 1 minus x. So we get 2a times 1 minus x, b times 1 plus x. And if we let x equals 1, we'll find 2 is a. The reason we picked x is 1 is because it makes this first bracket 0. And this one b, 1 plus 1. So therefore 2b is 2. So therefore b is 1. And then if we let x is minus 1, we'll get 2a1 minus 1 plus b times 1 minus 1. So this time that bit's 0. So we'll get 2a is equals to 2. So therefore a is also equals to 1. So we now need the integral. We can say the integral of 2 of 1 minus x squared dx is actually the same as the integral of, because with 2, this is 2 over 1 minus x squared, and a is 1, and b is 1 as well. So it's the integral of 1 over 1 plus x plus 1 over 1 minus x dx. You can say this is the integral of 1 over 1 plus x. I'm going to multiply top and bottom of this next one by minus 1. Minus 1 over x minus 1. Explain what I've done there. 1 times minus 1 is minus 1. 1 minus x times minus 1 is x minus 1. Because I've done the same to the top and the bottom, it's an equivalent fraction to this dx. So it's going to be ln 1 plus x minus ln x minus 1, which is ln, I'll write it as x plus 1 over x minus 1. And it is plus c for this one because we haven't got any limits. Okay, I'm colouring in, aren't we? Let's colour in the answer there. Okay, right, part C. Use an appropriate technique to evaluate the integral x cubed e to the x. Now there's 2 ways of doing this. The standard way is integration by parts. So we've got the integral of u v dashed dx, uv minus the integral of v u dashed dx. Okay, and what we have is that the x cubed is algebra and the e to the x is exponential. So we think about late, the one that comes, the letter of the type of function that we've got, the initial, which falls to the left, is the one that we call the u. So u is x cubed, and v dashed is e to the x. So v is also e to the x, because the integral of e to the x is e to the x, and u dashed is 3x squared. So substituting into integration by parts, this is going to be, so what, I've got this bit here sorted out, that's the x cubed, that's the e to the x. uv, so it's going to be x cubed e to the x, minus the integral, and look, it's v u dashed, so it's e to the x times 3x squared dx. So x cubed e to the x minus, I'm going to write this as 3 integral x squared e to the x dx. So we've got a second, I'm going to show you a much quicker way to do this in a minute, but I've got a second integral to do here. This is the typical, traditional way of doing it that I've been taught. But a student showed me a much quicker way, and I'm going to write that up as well. So we pick u is x squared, u dashed is 2x, that's that differentiated. V dashed is e to the x. So v is also e to the x. This is x cubed e to the x minus 3, and then we have to do uv minus the integral of v du dx, 2x e to the x dx. So x cubed e to the x, multiply it inside the curly brackets by 3, 3x squared e to the x plus 3 times the integral, and I'm going to bring the 2 out as well, x e to the x dx, just to keep neat. So I've got another integration by parts. So I've got u is x, therefore u dashed is 1, v dashed is e to the x, v is also e to the x. This is x cubed e to the x minus 3x squared e to the x plus 6. We have to do a uv again, x e to the x minus the integral of v du dx, dx. So this is x cubed e to the x, 3x squared e to the x plus 6x e to the x minus 6. The integral of e to the x is e to the x. So it's minus 6 e to the x plus c. Okay, so that's a bit fiddly. It's quite repetitive. But if you've got the way, a student should it this way, if you've got that u is algebra and v dashed is either exponential or trigonometry, then you can use this method. So we'll go back to the original, x cubed e to the x dx. So u is the algebra and v dashed is e to the x. So we say that u is x cubed, v dashed is e to the x. And what we do is we differentiate the u down to 0. And then we integrate the v up to the point where it's next to the 0. And then every second one gets multiplied by a minus on the u side. And then we do that one, that one, that one, and that one. Combine well together. So we can say the integral of x cubed e to the x dx is, so we do the top one here, look, x cubed times e to the x. And then it's minus 3x squared e to the x plus 6x e to the x minus 6 e to the x plus c. So see, that's a lot less writing and more chance of getting it correct with all the minus signs. But it only works if u is algebra and the v dashed is exponential or trig. So if it's algebra with exponential or algebra with trig, you can use this one. So the answer there, but I don't mind which way you do it. It's entirely up to you. With this one, because it was an x cubed and you have to run through this process quite a few times, it's quite good to have a shortcut. But yeah, if it was x squared, it wouldn't make much difference, I don't think. Right, D. Find the area bounded by the curves y equals 2x squared plus 1 and y, which looks like this. It's going to not like that, is it? I knew that. 2x squared plus 1. That's what y equals 2x squared plus 1 looks like. That's going to go through 1 there. 3x plus 3 looks like that. So we've got to work out this area here. Okay, so first of all we need to find out where the curve and the line intersect. So we need these x values here. So we can say 2x squared plus 1 equals 3x plus 3. So therefore 2x squared minus 3x minus 2 is 0. So what I've done there, I've taken 3x from each side and then taken 3 off the 1, minus 2. This will factorise. But you could use the quadratic formula if you so wished. If you can't spot the factorisation, I'll do that by the side as well in a minute. So it's 2x, and it's going to be a 2 and a 1. And I want a minus. I can do all that in my head, and I'll explain what I did in my head. 2x at 2x squared. Then we can get 2 is a prime number, so it's got to be 2x and x. This 2 is also going to be a prime number, so it's got to be 2 and 1, but it could be 2 there or 1 there, 2 there or 1 there, and one of them's got to be negative. Now we want minus 3x when we add them together once they've been multiplied. So if I put the 2 with the 2, that gives us minus 4, minus, and then plus 1x. It makes minus 3x. If you're not sure about that, you could always say, you've got 2x squared, minus 3x minus 2 equals 0. X is minus b, plus minus, square root, b squared minus 4 times a times c, all divided by 2a. So it's 3 plus or minus the square root. And then this is going to be 9 plus 16, 25 over 4. So it's 3 plus or minus 5 over 4. 8 over 4 minus 2 over 4. So it's 2 or minus a half. the plus 2 means there's a factor. This plus 2 means there's this factor of x minus 2. And then the minus a half, that corresponds to this factor, but you write it as 2x because you need a 2 there. Actually, we're not factorising. We can just say, therefore, x is minus a half, or x is 2. We're not factorising anyway. We just need to get the values of x, which we can find like this. Right. Oh, that's not very neat, is it? Let's just make it neater. Okay, something like that. Right, so that's our diagram. There's the minus a half, and there's the 2. So basically, what we have to do, if we do the area under the line, the 2x squared plus 1, and by under the line it means between the x-axis and the line, and then we subtract the area under the curve, we'll be left with the green shaded area. So under the line, we need the integral from minus a half to 2, so 2 there. And the line is the 3x plus 3 dx. 3x squared over 2 plus 3x between 2 minus a half. And x is equals to 2, so this is 3 times 4, which is 12 over 2, which is 6, plus 3 times 2, which is 6, minus a half in there now. We subtract, and we've got to put in minus a half. Well, minus a half squared is plus a quarter, so multiplied by 3, 3 quarters, divided by 2, 3/8 minus 3 over 2, which is 12. And then 3 over 2 is the same as 12 over 8. So we've got minus 3/8 minus 12/8. Three eighths. Just done this on the calculator, I'm getting distracted a bit. 3 quarters, 3/8, 3/8. Minus 3 over 2. 3/8 minus 12/8 minus 9/8 minus 9/8. So this is 12 plus 1 and 1/8. So it's 13 and 1/8. Let's do the integral under the curve now. Integral from minus a half to 2 of 2x squared plus 1 dx. I can do this one on my calculator, I think. Well, the arithmetic part. So it's going to be 3. It's not. It's going to be 2x cubed over 3 plus x between 2 and minus a half. So 2 cubed is 8. So it's 16 thirds plus 2 minus... I'm going to do the next one on the calculator. 2 times minus 0.5 cubed divided by 3. This calculator hasn't got an S to D button. We'll just put it in. Minus a half cubed is minus 1/8 times 2 minus 1/4 divided by 3 minus 1/12. And then minus 1/2. So this is, I'll just do all that on the calculator, 16 divided by 3 plus 2 plus 1 divided by 12 plus 1 divided by 2, 7.916 recurring. Okay, and so the overall answer that we want is 13 and 1/8. Take away 7.916 recurring. 13.125. Take away answer 5.21. Okay, that's the answer for that one. Right, we're on to A3 now. Find the solution of the first order differential equation. I've written them up here. What given by x squared dy by dx plus 3xy equals 7, or y is 3 when x is 1. Okay, so hopefully by now you've seen the videos that I've done on the notes that I've done with the differential equations. This question 3 is all about differential equations section. The question 2 is all about the integration. Right. Okay. Now this is a first order differential equation. First step 1, you've got to divide through. You've got to make sure that the coefficient of dy by dx is 1. So we've got to divide through by x squared. Dy by dx plus, I'm getting lots of emails again, distracting me. Divide by x squared, 3x over x squared y equals 7 over x squared. And these will cancel. That will cancel down to a 1. Then step 2 is find the integrating factor. The integrating factor is the exponential of the integral 3 over x dx. The exponential of 3 ln x, which is the exponential of ln x cubed, which is just x cubed. And then step 3, multiply through by the x cubed. X cubed dy by dx plus 3 x cubed over x times y equals 7 x cubed over x squared. So that cancels with one of those to make a 2. That cancels with one of those to make a 1, which we don't need to write down. Then by observation we can see that this side is d by dx of x cubed y is equals to 7x. Okay, and that's because, I explained this in the in the integrated differential equations integrating factor method video. If you differentiate this with a product rule, look, first times the derivative of the second is that one, then it's plus second times the derivative of the first, which is that one. So that's a product rule, the answer of a product rule, so that's what it was. That's the original product. So x cubed over y, 7x squared over 2, plus c. We integrate both sides with respect to x, that is. So y is 7x squared over 2x cubed plus c over x cubed. And they cancel. That was step 3 to arrange that, and I guess step 4 starts there, where we actually integrate both sides. So what we can do next is we've got to find c. Now this isn't in every question, but it's in here, so I won't really give this a step, but it's step 5. So we substitute, y is 3, x is 1. So 3 is 7 over 2x, and the x is 1. 7 over 2 times 1 plus c over 1 cubed. Therefore 7 over 2 times 1 is 3.5 plus c over 1 cubed is c over 1, which is c. So therefore c is minus a half. And y is 7 over 2x. That should be 0.5 is a half. Minus 0.5 over x cubed. Colour that in, and then we're ready to go again. Part B. Find the general solution of the second order differential equation given by d2y by dx squared plus 4dy by dx minus 5y is 26 sin x. So when we do ones like this is a second order one. Complementary function, first of all. And what we can do there is say that it's k squared plus 4k minus 5 is 0. This is k plus 5, k minus 1 is 0. So k is minus 5, k is 1. This is where e to the kx is a solution. So therefore, the complementary function is a e to the minus 5x plus b e to the x. Okay, so a bit more information about what I'm doing there is in the notes, but you know, as far as for an exam, I would keep it neat and efficient.
I don't know that one.
Alexa. Particular is listening in to me. Better unplug it. Right. Particular integral now. Okay, so for this one, when we've got a sine x on the right or a cos x on the right, you try why the particular integral is. We've got a and b already, so we have c cos x plus d sine x. I'll just call it y for now, just so you don't get too cluttered. Okay, then we're going to substitute this into the left-hand side and work out the c and d. So y dashed, which is the dy by dx, but y dashed is a bit easy to write. Cosine differentiates to minus sine, and sine differentiates to cosine. Second derivative, d2y by dx squared. Minus sine differentiates to minus cos x, and cosine differentiates to minus sine x. Using that sine, cosine, minus cosine, that what people like. Okay, so if you watch here, look, cosine to minus sine to minus cosine, sine, cosine, minus sine. Right, substituting to the left. This could get messy if we're not careful. Let's see, I'll try and do it in a little table to keep it neater. d2y by dx squared plus 4 dy by dx minus 5y 26 sine x. Okay, so d2y by dx squared. If I put all the cos x's in one line and then all the sine x's in the other, and then make it a bit neater. d2y by dx squared, that's a minus c for the cos x. I don't need to write cos x all the time there as well. So what I've done here, d2y by dx squared, y double dashed, is minus c for the cos x there, minus d for the sine x. And then we've got 4 dy by dx, which is minus 4c for the sine x, plus 4d for the cos x, minus 5y, minus 5c, minus 5d. And we haven't got any cos x's, but we've got 26 sine x's. So we're in it with simultaneous equations. So this is 4d minus 6c is 0, and this is minus 6d minus 4c is 0. Okay, call that equation 1 and that equation 2. Simultaneous equations, I'll write on the next page. 4d minus 6c is 0. And that was equation 1. Minus 6d minus 4c, am I right there? No, they're not both equals to 0. That second one, that's equals to 26. Right, equals to 26, and that was equation 2. Right, first of all, both of these are begging to be divided by 2. So 2d minus 3c is 0. Minus 3d minus 2c is 18. So this implies that d, add 3c to each side and divide by 2. Okay, that's rearranging that one. I'm going to call that equation 3. Equation 4, once they've been divided. Substitute d equals 3 over 2c in equation 4. And we get minus 3 times 3 over 2c minus 2c is 13. So minus 9 over 2c. 2c is actually 4 over 2c. It's 13. Multiply everything by 2. Minus 9c minus 4c is 26. So we've got minus 13c is 26. So therefore c is minus 2. Okay. Just trying to rub that little blob. It's not going to happen. And then substitute for c in star. D is 3 over 2c. So d is 3 over 2 times minus 2. So therefore d is minus 3. And we have our solution. So the particular integral, c cos d sine, is c, which is minus 2, cos x minus 3 sine x. And eventually we have y, the solution, is the complementary function, which is this here, plus the particular integral, which is this here. So a e to the minus 5x plus b e to the x minus 2 cos x minus 3 sine x. And that's how we complete the May 2016 questions.